is this idea that if this is 127, then the angle opposite of that needed to be 127. And then we talked about consecutive angles. So, like angle 27 is consecutive to E and G, they're right next to each other. And we talked about how consecutive angles are supplementary. So, this angle and this angle have to add up to be 180. So, if I did 180 minus 127, whatever remains would have to be this missing angle right here. All right. So that's going to be, 53 degrees. So for letter A, once we've kind of filled in this figure, that's pretty easy. Angle E, we can just look at the graph, and we know that that's a 53-degree angle. All right. Angle D, though, is not even shown. Like, we don't have that drawn into our graph. Write down what we should be able to do that. See if we can do that before I show you how. First time I've asked it, but we certainly have talked about it like this. All right, what do we think? What should angle D be here? Any thoughts? Nora? Good. How'd you know that, Nora? Good. So the first thing she said is that H, which is the one that we know, so that's the one that we can look at, has to be the same as D. Because when we have that similarity statement, the way they're ordered is basically saying those, so like the fourth set of angles there have to be congruent. Those are our corresponding angles. So D and H have to be the same. So while we don't know what D is, we do know that H was that 127. And if that's 127, then that means the corresponding angle D would also have to be 127. Okay? Good. All right. This similarity statement, wrote it a little bit differently. Understand sort of how this got set up. What I did first is I did A over B. So that's this here. So those first two letters in the first one. And then what I put underneath is, let me do this in blue, is B over C. So that's the second and the third letter in the first one. So when we now go to that other side, both of these have to come from the second part of that similarity statement. So since AB was the first two terms listed here, you'd have to use the first two terms listed in the other side. And then since B and C were the second and third, that would be equivalent to the second and the third over here, which is F and G, and that's what I have written in. All right. All right, D. Last one real quick. Do that. All right, and Ella, what do you got? Good. E and H. If I can get my pen to work. Let me try that again. Yeah, so that should be EH. Oh, there. Try this one more time. These want to work, Mr. Kupitz? Okay, it's EH. All right. All right. Do those guys real quick while I try to get a pen to work. And then we'll kind of get into what the new idea is today. This is what we just quizzed on, what we've been doing here the last couple of days, but kind of just changing the orientation of these triangles. They don't look exactly like each other. They've been rotated. And see if we can kind of match everything up. Yeah, I don't know what's going on. I'm going to keep this handy, though. All right. I guess we'll keep it there. Okay, so again, you have little pieces here and there, and then we've got to kind of understand old stuff with the new idea of similarity and the similarity statement and how these things all correspond. Sort of, again, kind of like a little puzzle, put all of this together so that we can answer these questions. So I give you one angle on this triangle. I give you one angle on this triangle. We have two sides here. We have one side over there. So in terms of the first two, hopefully with these guys, the angles hopefully were the easiest of them. When we look at these triangles here, if we understand that angle B is the second letter listed here, that means the second letter listed here, R, has to be its corresponding angle. So if we know that B is 53, then that means over here, angle R must also be 53 degrees. All right, that's a bad 53. And then in the same way, if we knew that angle Q was 46, Q is the first letter listed, that means angle A, the first letter listed in the other one, must also be 46. Then we have our 180 degree idea. These have to be congruent as well. So these would add up to be what, 99. So if we did 180, subtract away the 53 and the 46, what was that, 81? That should give us 81 degrees. And then now we're all set to answer these two questions. All right. So angle A would be that 46 degrees. And then angle S would have to be 81 degrees. All right. So again, just little bits and pieces, understanding kind of everything that we now have available to us, put that together. Hopefully we can get those angles quickly. And then now this is where it gets a little trickier when they're not oriented in the same direction, where these triangles are rotated and they don't look exactly like each other. So if I want you to find RS, let me clean this up a little bit. So let me get rid of some of these shadings. So I want you to find RS. Where's RS? RS is up here. So that's kind of like our variable. I don't give you the X. So we'll write that as the X. That's what we are trying to solve for. That's the answer to this question, the length of RS. So we obviously have to use this one. We would then want to figure out what side corresponds to that so that we can set up our first fraction. So if RS is X, again, it's not quite as easy as just looking at it. My eraser doesn't want to work here. There we go. I would just want to understand RS is the second and the third letter listed in that second statement. So that would mean BC, the second and the third letter listed in the first statement, would have to be its corresponding side. So BC is right here. Okay, so the X and the 18 go together. It's up to you how you want to set up your proportion here. I'm going to write these as the large value over the smaller value. So for me, I'm going to put the 18 on top, and I'm going to put the X on the bottom. Again, there's different ways, obviously, we've talked about that you can do that. Then we need to find another set of corresponding sides. All right, so if we kind of look at what else we are given, in this triangle, we are given that, in the big triangle, we are given that the other side that we know is a 6. So in the larger triangle, so again, I got to go large over small, we know that this side is a 6. If you look at what AC is, A is the first and the third term. In the other triangle, the first and the third term is Q and S. So Q and S is this right here. So the bigger one is the 6, the smaller one is the 5. That's the proportion. That's what we then cross multiply and then solve. All right, pretty easy from everybody was getting those right. I graded some of them this morning. And most of us understand these little proportions pretty well. So if you crisscross multiply those, you get 90 is equal to 6x. And then, what is that, 15? And then our x is a 15, okay? So largely the same stuff we just quizzed on, a little sneakier, rotating some things, just giving you one of the two shapes, really kind of relying on that statement. But for the most part, a little review. We're going to continue that on. with the new stuff, but obviously we're going to add some new things to it. All right, so today, what we're going to talk about specifically is similar and then triangles. So we've been dealing with all kinds of different shapes recently. We've done some quadrilaterals, but today's focus, the set of notes, is really just on triangles. So the first thing, remember, if two polygons are similar, there are two things that have to be true. That is, all corresponding angles. Make this bigger so I can write bigger. So all corresponding angles need to be congruent. Yeah, why does that not work? All right, so that's the first thing. And then the second thing is all corresponding sides. Oh my God. Have the same ratio. Okay, that's our scale factor we would talk about depending which direction you're going to go, but they're all in the same ratio. Okay, so when we're dealing specifically with triangles, we can shorten this a little bit where we don't need to know every single angle. We don't need to know every side to kind of prove it. With triangles, there's a couple easier routes that we can take with that. That doesn't make us know every single angle and every single side. All right, and there's three ways that we're going to do this, and that's what you're going to fill in here in a second. So it says there are three ways to prove triangles are congruent. The first way you're going to write is what is going to be called angle. Okay, and we'll talk about what that means here in a moment, but that's what we're going to write down for that. All right, a second way is with what we would call side. Oh my gosh. Angle, side. All right, so we have angle, angle, side, angle, side. And then our third one that we're going to be using as we show that triangles are similar to each other is going to be side, side, side. Okay, those are little theorems that we would be saying. When we use this guy here, the little squiggly that we have been using, so this shouldn't necessarily be new, but we use that to distinguish between the idea of the triangles being similar, so same shape, but just different sizes, versus the idea of congruent, which means not only the same shape, but they're also the same size. All right, so similar just means they look alike, different sizes. Just what we just did. You just did on the quiz yesterday. You dilated some, you made them bigger, you made them smaller. Those are all similar, certainly not congruent. All right, so let's now talk kind of about what these all are implying. So when you see angle, angle, when we start using this in the future, we're really just going to abbreviate it to be AA. So whenever we write this little just AA, we're saying that by the angle, angle theorem, these triangles have to be congruent. So here's what that theorem says. It says if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar by what we would say is the angle, angle theorem. So what that simply means, if I tell you that this angle here, we'll say it's about a 70-degree angle. If I come over to its corresponding angle on the other triangle, and this is 70 degrees, we've taken care of one of these angles up here. All right, so we currently have one set of angles that are congruent. If I then tell you that this angle up here, we'll say that this is a little less than 90, so that's 80, and then this guy is also 80. Now we have two sets of angles that are congruent. If we know that, it guarantees that these two things that we're always looking for are going to be true without having to actually go through and prove it all. All right. So if we ever get to the point that we have two sets of angles that are congruent, we know that these triangles are similar. All right. Wouldn't that also then mean the third angles also have to be congruent? Okay. That's sort of kind of the premise of that. And then we just kind of stretch it out, make it bigger or smaller. Okay. So that's the angle, angle theorem. All right. If we say side, angle, side, we're going to abbreviate that as well. So if we ever just write SAS, that is an abbreviation for side, angle, side. The order of this is important. So notice how I write the S and then the angle is in between the next S and the previous S. It has to be in this order. So if I come down here, let's start with a side. All right, so let's say this side here, I'll highlight this one in blue. And then this side here. And then if we pick one of these angles, I'm going to pick the angle on top. So this guy. And then its corresponding angle over here. In order to be side, angle, side, that angle has to be in between the two sides that we're dealing with. So of the sides that remain, if I call this side 1 and this side 2 is the one that would have that angle in between our two sides. So if I had this side here and this side here, notice how I have a side and then I have an angle and then I have a side. It's like sandwiched in between those two consecutive sides. It has to be in that order. Okay, we can't have two sides and then another angle off in the corner. It's got to be the angle in between. When that's the case, what we are looking for is if two corresponding sides are proportional to each other. So I'm going to have you add some other stuff here. So let's say that the blue one, actually, let me erase these now. Let's say this blue side was 2 and this blue side is 6. See how that one is 3 times bigger? Then let's say this was 5 and this was 15. Do you agree that's also 3 times bigger? So those are proportional to each other, 2 to 3, 5 to 15. And this angle is congruent. So we'll say this is about an 80-degree angle. So as long as the two sides are proportional to each other and the included angle there is congruent, then we can say that all those things are going to be satisfied, that all angles are congruent and all sides are proportional. Okay, so that's side, angle, side. And then the third and final one is side, side, side. So at this point, you're all pretty bright people. We know we're just going to put SSS. So whenever you see SSS, that stands for side, side, side. What that now just means, we may not need to know any angles. So if we don't know any of the angles, however, if we do know that all 3 pairs of corresponding sides are proportional, then that would guarantee the angles are all congruent. It guarantees we satisfy our 2 conditions. So similar, let's say this was 3. We'll say this triangle is 3, 4, 5. If I go to the other triangle, let's say I take that 3 and double it, so that becomes a 6. As long as all the sides then are twice as big or just have the same ratio, even if we don't know any of these angles, we are assured that those 2 triangles are similar. Okay, so if we know all 3 sides, all right, are proportional, then we know that these are going to be similar triangles. So it's just 3. So as we go through all of these, I'll write this down where we can kind of see all of them. It's either angle, angle, side, angle, side, or side, side, side in order for us to justify any of these. All right. So in this first one, it says for all of these, is your triangle ABC, so this will be the ABC in this one, similar to triangle XYZ? When we look at these, notice how the first 2 have an angle involved. When we look at letter A, do I give you any angle measures? No. So the only real way we're going to be able to test this to see if it's true or not, see if they're similar, is with the side, side, side idea, because we don't have any angles in these triangles. So what has to happen, if I take this side here and I compare it to its corresponding side here, I would get a 6 over a 4. So that has a ratio of 2 to 3, 2 over 3. What has to happen then in order for side, side, side to work, I would need to do this side and its corresponding side and find that ratio. And since I went bigger to smaller here, make sure you do the same here. Does 9/6. Wait, I screwed up. All right, just let me know when I screw up. This should be 3 over 2, correct? 6 over 4. I keyed this up earlier and I knew this was a yes. And now it was going to be wrong. All right, do the red ones also reduce down to be 3 over 2? Yeah, so we're going to write that. And then last but not least, when we do these sides here, the corresponding sides, if I did 12 over 8, these are both divisible by 4. Those also reduce down to be 3/2. So the first side, the second side, and the third side all have the same ratio. That's what side, side, side means. So in this case, you're going to put yes. And we would just say because of side, side, side. That's the theorem we would use to justify that, yeah, those are in fact similar triangles. Okay. All right, when we go to letter B, notice what you're given. So now let me erase what I have highlighted up here. Notice how now you were given this side here, this side here. Then you were given a second set of sides, this one and this one. Do we know the third side, though, like we did in the previous one? No. So it's probably not going to be side, side, side for this one because we don't know the third one, unless we wanted to try to figure it out. But notice how we do have an angle in this one. So these both deal with angles, angle, angle, side, side. But of these two, this requires you to know two different angles. We only know one. We know one angle here. We know one angle here. So here's what we're hoping for. We're kind of hoping this is a side angle side. So in order for that to be true, the black sides have to be proportional. So I'm going to take the 6 and the 3. If I did 6 to 3, notice how that reduces down to be a 2. If I do the red side to the red side, 10 to 5, that is also 2. So are both of these sides proportional to each other? And is the included angle there congruent as well? Yes. So you're going to say yes. And in this case, you would say because of side angle side. That guarantees that all the other angles are also congruent to each other. And then this third side would also be proportional. Okay. Okay, so letter C. Again, kind of look and see what we have. Let me write these again so we always know which ones are our options. It's these three. All right, side, 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 angle, 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 side, angle, side. If we look, we have one set of corresponding sides here. We have one set of corresponding sides here. We also have that included angle. So this sets up to hopefully use side, angle, side. All right, that's what we would be hoping for. We have the two sides and the angle that's included. So when we test these, if I do the red first, I'm going to put the bigger over the smaller. So 8 over 5. This doesn't reduce, so I'm going to write this as a decimal. So I'm going to write this as the decimal 1.6, all right, since we can't reduce that one. When we do the black sides, we're going to do the bigger one over the smaller one, 4.4 over 3, which again, that doesn't reduce. So as a decimal, that is the whole 1.3 repeat. Do these have the same ratio? No. So just because we have a side angle and a side that are marked and we know them doesn't necessarily mean they're similar. They've still got to check those ideas that these are congruent. The angles need to be congruent. That was fine. But since these are not the same ratio, we would say that no, these are not similar triangles. All right. All right. Try letter D. See if we're understanding this at all. It's kind of weird. A little different stuff than what we've been doing. So see what you think. All right. This should be the easiest one to kind of recognize what we're hoping for, like which of these three options we're really considering. Because if you look, there are no angles given. This obviously needs two angles. This would need one angle. You aren't given any angles, but you are given all three sides. That doesn't mean this is a yes. Right? Just because you have all three sides, you're not going to put a yes down. We need to make sure that these corresponding sides, so the 9 and the 6, so if I did 9 over 6 and reduce that, that's the ratio of the sides that I have in black. They all better have that same ratio now. So if I go from this side to this side, does 12 over 8 reduce down to be 3 halves as well? Yeah, so far so good. And then our final side, this 15 compared to the 10, does that also reduce down to be 3 halves? Yeah. So by side, all three sides have the same ratio to each other. You would say yes, and then you would put down the reasoning, and it's the side. All right. All right. 21, or not 21, E. I see the 21 right there. All right. If you look at E, see what you think there. I'm going to write all these options down again. So angle, side, side angle, side. Look at what you were given. Look at what I gave you. In this one, do I give you all three sides kind of process elimination? No. So there's no way we're going to be able to do that one because we don't know all those sides. Okay. We know two sides here. We know two sides here. If I go to the angles, do we have two angles? If I look at this yellow triangle here, do I know two angles within that yellow triangle? No. Do I know two angles within this yellow triangle? No. So we can't say that we know two angles as well. So the only one you're kind of hoping for is a side angle side. So let's look at a couple of sides we have. So let's do 21. It's hard to even know which one. I'm going to guess a little bit. To me, this looks like the longest side. So let's say we compare that to the 6. And again, it's not even really easy for us to know which ones correspond to each other. All right, then let's say the 14 matches up with this 4 right here. If I am trying to prove side angle side, this guy's okay, at least in terms of the order, because I have a side and then I have an angle and then I have the next side. I have this included angle between the two lines that I have shaded. So for this one, wouldn't angle B, isn't this the angle that should be included by those two sides that we know? And do we know what that angle is? No, we don't know these are similar. You can't say that that's 45. We don't know that those actually match up. All right, so in this case, this is another instance where we would say, no, these are not similar triangles. We don't have enough information to prove either one of these little theorems here. So that is a no. All right. Even if you set these up, so, again, be careful. Let's say I did 21 over 6. If I reduce that, that's going to be 7 halves. If I do 14 over 4, that's going to reduce down to be 7 halves. So we're satisfying that idea. But again, we have to have the included angles be the same, and we don't know that they are. Okay. All right, last one, F of these. So say yes, and then use one of the 3, or say no. All right, this is another one, all of them really, a little bit of a process of elimination. Are you given any side lengths at all in either of these triangles? No. So it can't be side. It can't be side angle side. Our only hope then would be angle. And if we can't use that, then it's going to be a no. All right. When we look at these, do we know that at least two angles within these triangles are congruent to each other? Yeah. Why, Nick? Why do you think that? Or Tyler? Okay. So the 100s are obvious. So those are definitely congruent. And then do we have another set that we know are congruent? You were right the first time. Okay, how do we know that for a fact? So by that I mean, how can I know what this angle right here is? I know this one, I know this one. Can't we figure that one out? Yeah, by doing what? So in a triangle, we have to have 180. We had 130 already. So if we did that, we know this triangle, this angle must be 50 degrees. Isn't one of the other angles in that other triangle 50 degrees as well? That then shows us that, yeah, for sure, we have two angles that are congruent. So through the idea of angle, those triangles are similar. All right. All right. And then the last one, little problems here. It says, find the value of x in each pair of similar triangles. A should be nice. Do letter A real quick. All right. Setting that one up. Omar, how'd you set that one up?
X over 10 equals 27 over 15. I mean, X over 15.
Okay. So he did the x, and again, yours could look different. Okay. Depending on the order, depending on what you put in the numerator, denominator, if you go big to small, little to big, these can look different. But he took the bigger bottom, compared it to the smaller bottom. So we did x over 15. So if he did that x over 15, then the other one would be what, Omar? Good. Then he would have to do this big side here compared to the big side in the smaller triangle over a 10. And again, yours might very much look different, and that's okay. So when we crisscross these, what did you get for this, Omar? Is that what you're plugging into your calculator? Okay, so 405. And then when we divide that, we get what, Omar? Good. So again, if this was different, if your setup was different, which is quite possible depending on the order in which you did it, as long as you get 40.5, then your setup was fine, even though it might look different. Okay. That's a nice one. That I could have put on yesterday's quiz without a second thought, something we should be able to do. Letter B, same idea, little trickier shapes as we kind of start to progress in this module. See if you can set up something for B. Okay. This one's a little sneakier. First, we have to like here, this is pretty obvious. We have two different triangles here. All right. They're separated from each other. They're drawn in exactly like each other. So A, hopefully, was really nice. B is a little sneakier. What you have to recognize is we have a triangle here, the small triangle. And then within or around that, we could actually draw in a bigger triangle. So if we could separate those, we'd like to actually kind of be able to reach in here, grab that red triangle. If I could grab that and like slide it down, we would see two different triangles. Here, they're just embedded inside of each other. Okay. But it's again the kind of same idea. We want corresponding sides and we want to set up a proportion in order to do that. So we need a fraction on the left, we need a fraction on the right. All right, anybody get that? You think they set this up right? We're solving for the x there, so that obviously going to have to be somewhere in this fraction in order to do this. Lily, what you got? Okay, so stop there. So she did 5 over 15. So what she did by setting up 5 over 15, she took the top side of the small triangle. So she went the small on top. And then she put that over the top side of this big triangle. All right. So when she sets up this next one, she better be doing corresponding sides with whichever those corresponding sides are. The small one better be here, and the big one better be here. All right. So that'd be what, Lily? Good. So she took the right-hand side of the red one, which was the 3, and then the right-hand side of the big one, which was the x. Okay. And again, yours might look a little different depending on the order. But if you solve yours, and then this is now good, everybody was getting these right when I was grading the quizzes. You crisscross, you get 5x equals a 45, as long as you get, what'd you get, Lily? Good. As long as you get that x value of 9, you're good. Okay, your setup was correct. All right. All right, one more with kind of a weird shape, and then D you'll be able to do without a problem. Try C. Oh, also, I'm going to keying this up. This 12 belongs right here. It's the length of that. So I would just cross it out if I were you. It's just confusing. So it looks like it's an angle. It's not that angle. It's this side length right here. All right, this one, pretty obvious. We have 2 triangles here. They're connected. They share a point. But again, the orientation's off a little bit. They're not drawn in kind of the exact same way. So it's just in terms of identifying our corresponding sides. Certainly, we need to include this x, and then we just need to know like what is its corresponding side. So if you can kind of look at these markings, notice how it goes from this single arc. So we have this arc right here drawn to where they intersect. So that x, I'm going to set up mine a little differently than I'm guessing other people would, just to show that it should still work. When we go to this other triangle, we want the side that goes from the single arc to where these intersect. So here is the single arc on the other side, and here's that intersection point. So the x and the 15 should be corresponding sides. All right. And then for me, I did the smaller one over the bigger one. So when I go to set up this next one, the 2 sides that we know that are the same, notice how we have in this one the single arc to the double arc. The one over here that goes single arc to the double arc is here. So these 2 sides are congruent or corresponding. I went small to big, so I have to put the 12 on top and the 20 on the bottom. All right. And then we solve. So we get 20x equals, what was 12 times 15 there? 180. So again, even if your setup was a little different, you should get 9 for that answer. All right. Okay. And then the next one, you can do that one. We don't necessarily need to do that together. Those are pretty obvious. If you can't do that one, yesterday's quiz would have been not a good experience. All right. And then wouldn't be a 4-day weekend without some homework. Get something to do. There you go. You can stop recording.